So lake schema on read access controls. The notion here is that we're going to put data into a lake or data in some blob storage or a cloud storage area, and we want to know how we can do filtered access controls, filtered data retrieval in those storage mechanisms without changing or dividing the data up on the storage itself. Kind of like you can do in a database table. I got a table with a bunch of columns in it, and this user's only allowed to see these columns, and this user's only allowed to see those columns. So there's really only, as near as I can tell, there's really only 3 ways to make this happen, right? And again, primarily I'm going to be talking about square record-oriented data. You can do these same techniques with other data. It gets a little complicated. Some data it's not going to work at all for, or it would be hard unless you built a specialized system like sound files or movie files or something like that. Those would be difficult. So the idea here is that we're going to filter the data on read as it is streamed back to the client with without having modified the way the data is actually organized on the disk for a specific set of users. So what kind of access controls are we talking about? What is the granularity of these? One we do is data set level access controls. These are super coarse grain. In a lot of ways, this is actually kind of the most basic control that's available, like in cloud storage. And it really only gives you all or nothing access based on your role. There's column level access controls where you, and again, we're not talking about optimizing the storage for this, although it might be a column or store. The idea is that there are certain columns like that contain sensitive data or other kinds of information, and subset of the users are only allowed to see certain columns. The final one is probably the most complicated to do, or not necessarily complicated, but has the most performance implications. And the notion here is that you would filter the rows of data based on the values in some columns. So there might be a privacy flag. And so when people run a query against a data store, there might be a data store with millions of rows in it, terabytes of data, and you would only retrieve back the rows that actually had the flag set in a certain way. And so those would be row level access controls, and they're usually based on some column or value or some business rule. So if we look at storage real quick, so this is the bottom tier in cloud blob store or object store, and that's typically the IAM role, some kind of cloud vendor, relatively coarse grain, works really well as long as you want access to the whole data set, and highly integrated with the cloud vendors, but very block level. So if we move up the stack, and I probably could have done this as a build out for 2 slides, but if you had cloud storage, if you move up a stack, what you can do a little bit is you could put a transparent proxy in there that does the filtering for you. Now, the client library and the transparent proxy have the disadvantage that they need to understand the format of the data coming back, because they're going to actually prune the data as it streams through that tier. So the yellow and the green tier, you're going to have to stream through and understand what the data looks like. The advantage of the cloud storage coarse grain controls is they don't care what the storage model is. But if you know what the data type looks like and how it's being retrieved, then you can do this filtering. So one of them would be a transparent or other semi-transparent proxy. And the idea there is you have something that looks like storage sitting in front of storage, and when you make a request, as the data is filtered back, it looks at its dictionary or meta catalog and tries to figure out what this user is allowed to see based on their authorizations. And it would remove the columns or the columns and rows based on the right criteria. The next level up would be the client library, and this actually could work the same way, using the same configuration data store. Instead of doing this in a network tier, though, between you and the data store, the client itself, all the data actually gets fetched back to the client, and then the client library is responsible for filtering this out. And this can work if you're on a platform where you trust the client library to not be bypassed, but we'll talk about that in a minute. The implementation of this can actually be hidden by a vendor in a higher level service. So like if you were to look at a Delta Lake or a lake formation or one of these other products where you have a higher level set of services, right? Those services actually end up having to implement this filtering because it's not implemented in the storage. If you need row and column filtering, they're either going to do it in a transparent proxy in their tier, or they're essentially doing it in their client. So the weird part is if you have an app and the app's called, I'm going to pick Athena here, but you could do the Azure Store, right? Like their really cool database thing they've got, the one that does all the different types of databases in one. that thing actually has a client built into it for the underlying storage, right? And so your app calls that as if it's a service, but to the data store, that service is actually a client. So the end result is anything that somebody has a product that has fine-grained access controls actually implements one of these. They either put something underneath their product offering or they embed it in the client in their product offering, but the net is the same. If you were going to build your own library for your own custom app, you would end up having to pick one of these. But for the finer grained controls, the only options are client library and a transparent proxy. So what are the pros and cons of that? Storage layer, totally awesome, right on the storage. Very coarse grained, works with any data type. Downside, can't do any filtering. Really can't filter through the data unless it knew the storage type. And also it's out of scope for most of the cloud storage. Now some of them have blob table store, and so that's a little different, but that's actually usually an abstraction built on top of an underlying bucket strategy, right? And what else? If you're going to do this in the storage layer and you're going to do this kind of data filtering, you have to understand all the underlying data types or some subset of the data types. And that's why this tends to get boosted up a level from that if we need it. Now, the Proxy Interceptor, man, pretty awesome. You can make this thing transparent. You can deploy it anywhere. It can be pretty highly performant, right? Because you're going to stream data through it. The downside is it can be pretty not highly performant, right? It can be pretty non-performant. And the reason is, where I worked before, we would be pulling terabytes of data through these cloud systems, and that meant the proxy had to be scaled wide enough that it could handle the parallel load. Like you do a Spark job and you're running 30 nodes or something like that, and then you got hundreds of those running at the same time. Your Proxy Interceptor tier has to be big enough to handle the concurrent load for streaming all the data and doing all the filtering at once. So that can jack the cost a little bit, a fair amount, and you have to be able to scale and manage those clusters. The other thing is, so one advantage of this, though, still, is if you wanted coarse grain access controls for a certain subset of consumers, if you do this in the Interceptor rather than the product, you can still get base level access control or access to the underlying storage and consume those as storage blobs. Or you can use it through the proxy tier with the filtering turned on. You just have to make sure that you limit who's allowed to access the underlying storage. So this is the usual case. The good news is that your greatest strength is your greatest weakness. You can bypass underlying storage to get better access, and the downside is some people, if it's misconfigured, will bypass the proxy tier to get access to the underlying storage. So if we look at driver-based controls, the pros, you push this thing all the way to the client, and you make them use a client to talk to your storage, and you don't let anybody any other way to get there. The good news is no proxy scaling issues. All the loads on the clients, right? So no matter how many clients you got, you never run out of gas. And you could build views in the client so that the consumer would actually think they're like doing some kind of view thing, and it would appear as a view, but it's really done in the client library. The cons, you got to trust all the clients. You got to trust that nobody can bypass thing. Nobody can put a side attack on this and go after the buffer, that there's no access to the data that's been streamed in prior to filtering, right? And all this sensitive data still ends up on the client. And I know a couple of cloud vendors have looked at this, moving some of this to the client so they wouldn't have to worry about scaling the proxy tier. But if I'm doing an audit, or you get audited, or you got some kind of finding, the fact that the sensitive data actually went to the machine and then got filtered, man, that is going to be a losing strategy. So my personal opinion, others may have a different opinion, is this is a bad idea. Now, I talked about this a minute ago, and there you can build a higher level abstractions on your data in the lake, and for certain data types, right? The ones that are supported by your data store. And that will actually give you this filtering view, right? And what's the beautiful thing about that is it's kind of transparent to you, and it gives you a legacy view that makes it look like a database so everybody understands how it works. And no extra tier is required for scaling because you already have this service tier that's got to run to give you that service tier abstraction. So this is just a minor upbeat on that. Now, that service tier still got to scale and you got to pay for that, but you were already doing it to use the servicing abstraction. And if you want, you can still go to the underlying controls, right? Because this isn't sitting down on the metal. You can give kind of macro access to certain consumers, like if you're doing sensitivity scanning or something else, they can still go at the raw storage, right? While at the same time, you get this higher level abstraction. The downside of this is, man, you can be really limited to certain vendors' products to make it work. So you get this great abstraction and it's great, but if you want to use some other product, like that abstraction layer is not going to be available in other companies' products. So you can get a little bit of vendor lock-in on this, or a fair amount, and so that's something to be, but you can get it faster to market, and you get the controls you want without having to stand up any of your own clusters. So in some cases, this is probably going to be the best thing, but I just want you to remember that really the controls, if it's done in a service on top of regular cloud storage, that the service actually implemented this in one of either the client library that it's consuming, or it implemented it in a transparent proxy to give it that level of abstraction, and then they have like a multi-tier architecture for their service. Filtering for cloud storage for schema on read can only be implemented 3 places. The cloud storage API, in some kind of transparent proxy tier, or in some kind of client library. It's up to you to figure out which one works for you, or you can kind of hide from it a little bit and pick some service that does this. And so it's just a balancing act to figure out which one works best for you. Have a great day.